Okay, friends, so let's chat about this idea of a margin of error and what that 28% actually is measuring. Okay, so we want to know what the US obesity rate in 2015 is, or in that case, was. There's two ways you can measure it, as we've just now discussed, via parameters or via statistics. But parameters, I'm just going to draw a line through, because the only way we could have possibly gotten a parameter or a parametric value is if we measured every single person, which we didn't do. So we know it's not a parameter. So that means it has to be a statistic, the 28%, which means they took a sample, in this case I think it was 175,000 people, which is a lot of people, and they found the percent of that sample that was obese by BMI measures, and it was 28% of that sample, so 28% of 175,000 people. Okay, but the problem is that no matter how big that sample is, it's not as big as the entire population of US adults. So that means that even if the study was done well, which we're giving them the hall pass on, this is not exactly equal to that. It's close. And here's how you measure closeness in a statistic. You add and subtract the margin of error to that number and create a range of values. So let's do the arithmetic first and then make sure we understand what it means. 28% plus or minus 0.2%. That's going to create two numbers. And those two numbers are called the endpoints of what's known as a confidence interval. It's not important to memorize that right now. We'll come back to that. So if I do 28% minus 0.2%, I end up with 27.8%. And if I add 0.2% to 28%, I get 28.2%. That's a range of numbers. It's a range of numbers from 27.8% to 28.2%. It's a range of values, in the middle of which is 28%. So what the margin of error allows you to do is to give you some wiggle room around the statistic when you're not 100% certain the statistic is exactly correct, which we know it's not, because we didn't ask everybody, we didn't measure everybody. So you put the wiggle room of the margin of error onto the statistic and create a range of values. You have to ask yourself this very simple question: what's more likely, that the obesity rate is exactly the same as the sample's rate, or that it's between these two values? It only takes you a second to realize this is more likely true than that. This is the big thing about statistics. You never know with 100% certainty if what you've collected is correct. You try to minimize the error. Saying that the obesity rate is exactly 28%, because that's what the sample is, you're putting a lot of faith in that number. It's more likely that it's around that number, that it's close to that number, and that's what the 0.2% gives you, is a wiggle room around that number. Now, that being said, we still don't know what the actual obesity rate in the population was back in 2015, nor will we ever. We didn't measure everybody. The best estimate from this Gallup Well-Being Index is that it's somewhere between 27.8% and 28.2%. So you might say to yourself, wait a minute, I remember reading in the Gallup Healthways Index that in 2014, it was 27.7%. That was the dot right before the end of the graph. Our graph went up to 28%. The dot right before that one was at 27.7%. And if I look at this range of values, that means in 2015, the lowest I think it could have been was 27.8. Well, that one's 27.7. That means all these numbers are bigger than that number. Doesn't that mean that can say with some kind of statistical certainty that the obesity rate is higher in 2015, because even with the plus or minus, even with the wiggle room around the 28, the lowest number in my interval is still bigger than the number that it was in 2014. It's a fun thing to think and believe. The problem is that the number in 2014 also had a margin of error. And what I've done is I've actually gone and found every single one of the Gallup Healthways margins of errors. Interestingly enough, they're different from each other. I don't know why, but I did collect them for you. And in the next video, we're going to take a look at what can actually be determined when you apply these margins of error.